Okay, this lesson is about absolute values and inequalities, so we're going to be solving and graphing just on a number line, absolute value equations and inequalities. So first, just a refresher on what absolute value is. Absolute value is the distance a number is from 0. And so since it's a distance is never negative. So when you take the absolute value of a number, you should never get a negative number. All right, you would never say like you walked -4 miles. That's not a thing. So for example, if we had the absolute value of 4, remember absolute value symbol is these vertical lines. The absolute value of 4 is just asking how far away from 0 is 4. 4 is 4 away from 0. If we wanted to do the absolute value of -22, this is asking how far away from 0 is -22. -22 is 22 away from 0. If we wanted to do absolute value of 0, again, it's asking how far away from 0 is 0. Well, 0 is 0, so it's 0 away from 0. And one thing to be careful of, notice here this negative was inside the absolute value. We were taking the absolute value of a negative number. We could have one where it's negative absolute value. And so here, this negative is not inside the absolute value. So we would first take the absolute value of 5, which is asking how far away from 5 is 0. Well, 5 is 5 away from 0, but then it's negative. It's the negative absolute value. So that is the only way you can end up with a negative number, is if the negative is outside of the absolute value. Okay, so to solve absolute value equations, you'll have something, an expression inside an absolute value symbol, and it's going to say it equals like 10, or it equals a number. So what we know about absolute values is there's two ways we could get 10 here. We could say that the absolute value of a positive 10 equals 10, but then there's also, we could have the absolute value of a -10 would also equal 10. So we have to account for both situations. One where the thing inside the absolute value is positive, because the absolute value would be positive, and one where the thing inside the absolute value is negative, because the absolute value would still be positive. So to solve absolute value equations, we need to write two equations. One where we set whatever is in the absolute value equal to the positive answer, and one where we set whatever is inside the absolute value equal to a negative answer. So you're going to set up, step 1 will be to set up two equations. One equal to the positive, and one equal to the negative. That'll make a little more sense when we do an example. And then once you have your two equations set up, you're just going to solve them both for x, or whatever the variable is. And then you're going to make sure you check your answers, meaning plug them back in and see if they're true. Because it is possible to have those extraneous solutions again, where you have kind of extra answers that aren't actually solutions. So let's do an example. So the absolute value of 2x minus 1. So we need to split this up into two equations. One where whatever is inside the absolute value is 2x minus 1 equal to the positive 5. That would be if we ended up with having a positive 5 in the absolute value. And then one where we take that 2x minus 1 and we set it equal to a -5, because the absolute value of -5 would still give us 5. And then we just solve both of those for x. So remember, we do order of operations in reverse, so deal with the addition or subtraction first. So I'll add 1 to both sides, and then divide by 2. So it'll give me x equals 3. And then we do the same thing with our other equation. Add 1 to both sides, and divide by 2. That'll give me x equals a -2. So we do have to check our answers still, so that just means we plug them in. So we're going to check And so we'll do absolute value of 2 times 3, just plugging in that x value, minus 1, and see what that equals. So the absolute value of, do this multiplication, 6 minus 1, which will be the absolute value of 5, which is 5. So that one's good, x equals 3 is a solution. And then if we check our second one, so we'll have the absolute value of 2 times negative 2 minus 1. Do this multiplication, we'll have the absolute value of negative 4 minus 1, which is the absolute value of negative 5, which is 5. So that means they are both solutions, x equals 3 and x equals negative 2. All right. With letter B. So for this one, the splitting up here that we do can only happen when the absolute value is completely by itself on one side of the equal sign. So over here in letter B, we have this 3 being multiplied and this minus 1. So we can't split up our equations yet. So can only split into 2 equations when absolute value is by itself. So that means first we have to solve for that absolute value, get that absolute value by itself. So order of operations in reverse. Deal with the addition or subtraction first. And then divide by 3. Okay, and now from here it's the same idea as letter A, where we can split it up and solve both equations. So I want you guys to go ahead and finish this one. Don't forget to check your answers at the end. All right, and then letter C. So this one, we have 2 t terms. We have a 2t over here and a 3t over here, and that's okay. But we do see the absolute value is by itself, so that means we can go right to the splitting up into 2 equations step. But in this case, our answer is a whole expression. So we need to kind of think about this in parentheses, where when we split it up, we'll have our 2t minus 3 equals positive 3t minus 2, so just as is. And then 1, where it'll be what's inside the absolute value, equals the negative 3t minus 2, and that negative would go to all the terms. So basically you're just switching the signs of all the terms. And then from here it's just solving for t. So get the t's together on one side and solve for t. So go ahead and finish letter C. Okay, so these were all equations where we had that equal sign. Now we're going to talk about inequalities. So a couple things with inequalities, we have a couple options. We have either less than, or less than or equal to, or greater than or equal to. And so when we have these inequalities with the absolute values, let's do an example. So if we had like the absolute value of x is less than 3. What this is saying is if we had a number line, now remember absolute value could be positive or negative inside there, right? We could have the absolute value of positive 2 be less than 3 because the absolute value of 2 is 2 and 2 is less than 3. But then what about a negative 2? Absolute value of negative 2 is also less than 3. So I have to keep in mind both possibilities. And so when we do that, that means we want, if we had our negative 3 and our positive 3, since it's only less than and not or equal to, we'll have open dots. Open since there's no equal to. And then in order for this inequality to be true, in order for whatever number we plug in to be less than 3, it's going to have to be in between -3 and 3. Right? And we can figure this out just by doing some test points. So if we tested like -4, this is saying that 4 is less than 3, which just is not true. So that means it has to be on the other side of that -3. And if we did we already tested the absolute value of 2 and -2, those both worked, which are both in this area here. If we test one over on this side, if we did the absolute value of 4, absolute value of 4 is 4, and 4 is not less than 3. So again, that one doesn't work. So it has to be, when it's less than, it's going to be in between these 2 points with open circles, because it can't equal -3 or 3, because if we did the absolute value of 3, that would give us 3 is less than 3, but that's not true. 3 is not less than 3. 3 is equal to 3. So that's why that one doesn't work either. So open circles and everything in between when we're less than. So this is kind of and. It's from between -3 and 3. And so to write that in interval notation, since it's open circles, we get parentheses. It goes from -3 to 3. Parentheses, since it's an open circle. And again, this is interval notation. Okay, less than or equal to would be very similar, but instead of having those open circles at 3 and -3, it's going to be a closed circle because it could equal 3 or -3, and that would be okay. So if we had the absolute value of x is less than or equal to 3, then it would be or equal to means we can have closed circles, and then it'll be everything in between. Again, we could test it, again, do some test points if we need to convince ourselves. But it's the same thing, just closed dots. And so with the notation, since it's closed, now we can use brackets. And it goes from -3 to +3. And it's the and, from -3, between -3 and 3. Just one interval. Okay, so that's both of these have only one interval when it's less than or equal to. Now, if it's greater than or equal to, now we have a special situation where it can be kind of two options. If we had x is greater than, absolute value of x is greater than 3, and if we had a number line with our -3 and our 3. So let's look at our positive first. If we wanted x to be greater than 3, that means it could not equal 3 because we want just greater than, not or equal to. But then it would be any numbers off to the right, going all the way to infinity. All right, any number greater than 3, the absolute value of that number will be greater than 3. And then it's the same thing but going the other way for the negatives. Not equal to -3, but anything less than -3 going all the way to -infinity. And again, we could prove it, do a couple test points if we did like the absolute value of -4. Absolute value of -4 is 4. 4 is greater than 3. But if we did one in the middle, like absolute value of 0, absolute value of 0 is 0, and 0 is not greater than 3. So that's why that one doesn't work. All right, and then notation-wise, whenever we have infinities, we have to use parentheses. And this goes from -infinity to -3, parentheses because it's open. So parentheses, or infinities always get parentheses, and if it's an open dot, it gets a parenthesis. And then there's this gap that we can't include anything in there. And so that's the or. And the notation for or is this little U symbol. So it can be from -infinity to -3, or from a +3 to a +infinity. And again, it's a parenthesis because it's an open circle, and it's a parenthesis because it's an infinity. And then greater than or equal to would be very similar, but instead of open dots, it'll be closed dots. So if we had the absolute value of x is greater than or equal to 3, have our 3 and our negative 3, it would go all the way including negative 3 and everything less than to a negative infinity, and then including positive 3 and everything greater than to positive infinity. And so to do our notation, infinity still get parentheses, but now we get a negative 3 that's included, so we get a bracket. And then again we have this gap here, which means it's or. That's that u. And then again a closed dot, so a bracket from 3 to positive infinity with a parenthesis. Okay, so less than or equal to has only one interval. Greater than or equal to has 2 intervals, which means we have to have that or symbol, that u. Okay, so we did an example. Letter A, we want to solve for x. So this is a less than, not or equal to, so that means we'll have the number line situation where it's the 2 open dots and everything in between. So to figure out what those are, we take our 2x minus 1 and we need that to be greater than, less than positive 5. Right, that would give us this going this direction. But then we also need it to be greater than negative 5. So we're going to have 2x minus 1 and then greater than negative 5. So you flip the inequality sign and you flip the sign of the answer. So we flip both. And again, having these pictures to look at can help you having those number line graphs. And then it's just solving for x. So you can kind of do our same order of operations in reverse to get x by itself. So we'll add 1 to both sides. We'll have 2x is less than 6. Then divide both sides by 2. So we'll have x is less than 3. Or, again, solve for x, so add 1. Divide by 2, divide by 2. We'll have x is greater than negative 2. So if we had our number line, we have a negative 2, we have a 3. We want everything to be greater than, but not equal to negative 2. So not equal to means open dot, greater than, and less than, but not equal to positive 3. So if we did our notation, they're both open dots, so we'll have parentheses. And it's a less than, so it's just the one interval from negative 2 to 3. All right. For letter B, again, we can't split anything up until we have the absolute value by itself. So we're going to deal with this multiplication and addition here. So we can subtract both sides by 2. And then divide by 2. Okay, and then this is a greater than or equal to. So again, our situation, if we had a negative 5 and a 5, remember greater than or equal to is going to go out from the middle with that gap in the middle. So it'll be a closed dot being less than negative 5 and a closed dot being greater than positive 5. So then we can split it up and write our two equations to mimic this graph here. So 2x minus 1 greater than 5, greater than or equal to 5, and 2x minus 1 less than or equal to negative 5. Again, flip both sides, or both signs. Okay, and then from there it's just a matter of solving for x and getting your interval notation. So go ahead and finish letter B. And then there's just a couple quick check questions and a self-assessment, and bring any questions you have to the Google Meet.